Hello everyone. Today let's solve the problem number 121. Best time to buy and sell stock. Right. So you can just go through the question and you can just go through the example to understand the question pretty well. So I'll just summarize the question for you guys so that it will be easier to understand. And after understanding the question, let's go with the further things. So first, what the question states here, we are given an array prices where iterated value of the prices, nothing but prices of I represents the price of a stock on the ith day. So we have been given prices where iterated value of the prices represents the price of a stock on the ith day, and the goal is to maximize the profit by choosing one day to buy the stock and a different future day to sell it. So if no profit can be made, we have to return 0. That's what they have given in the question. If no profit is made, if no profit can be made, then we have to return 0. I hope this is fine, right? So this is one thing, and let's go with the this one approach first. Let's discuss the approach first. Then after discussing the approach, let's go with the edge case and write the code and discuss the complexities, right? So let's discuss the approach step by step, right? First, let's just remember we'll be making use of the two-pointer approach here. Just give here, we'll be making use of the 2 pointers here because to traverse the array and to find the maximum profit, right? So let's see what will be the first step. So let's go with initializing the pointers. So I'll just give here initialize pointers, right? So this will be the first step. We will initialize the L. Basically, L represents the buying day, and let's start L at index 0. As usual, we'll be starting L at index 0 or start here. Let me give here 0, right? So also, the first day is the minimum price seen so far. So this we need to keep in mind. The first day is always the minimum price that has been seen so far, and we'll be making use of the loop to iterate over the remaining prices with the pointer R, nothing but the selling day, right? So left and right pointers, this will be at the basically R. While I say R, we'll be making use of the loop to iterate over the remaining prices with the pointer R, nothing but the selling day. I can just give here selling day. So we'll be making use of the 2 pointers L and R here. This is nothing but the initializing pointers. Let's move on with the second step here. Nothing but we have to compare the current price with the minimum price. So this is nothing but compare current price with minimum price here. So while I say comparing the current price with minimum price, I'm speaking of the condition if prices, so of we have considered 2 pointers, right? R and L. So if prices of R less than prices of L, then what we will do here, we will update L equals R. This one we have to keep in mind. We will update L equals R because we found a new minimum price to buy. This is the second step, right? So we are comparing the current price with the minimum price. Just remember this one. And finally, let's move to the third step. Nothing but the main step here, calculating the profit. Calculate profit I'll give here. So I hope this is clear, and we have to compute the profit as here we are computing in this way, prices of R minus prices of L. This is fine. Just to keep track of the maximum profit, we'll be making use of the variable max. So let's see that while we write the code. While we write the code, we'll understand this one very clearly, I assure that. So third step is we'll be going with calculating the profit, nothing but we'll be going with this one. profit of R minus prices of R minus prices of L. So just to keep track of the maximum profit, we'll be making use of the variable max. Just remember this one. And final step is we have to return the result, right? We have to just return the value of the max after completing the loop. Nothing but here we have to return the result. In this case, this will be the final step. This will be the approach that we'll be going with. So the next thing is we'll be discussing on the edge cases and then finally write the code and discuss the complexities, right? So I hope the approach is clear. So what we are doing here, so just give me a second here. First thing is we are going with the 2 pointers approach. We'll be initializing the pointers L and R, L to the start or the 0th index and R to the selling day, right? So the second thing is we'll compare the current price with the minimum price. When I say comparing the current price with the minimum price, we are going with prices of, when prices of R less than prices of L, then we are setting L equals R, right? So then we'll be calculating the profit. Just remember this one formula, and just to keep track of the maximum profit, we'll be making use of the variable max. Finally, what we'll do, we have to return the result. While I say we have to return the result, we have to return the value of the max. We have to return the value of the max after completing the loop. So this will be the approach, and let's discuss the edge case one by one, and then let's go with the edge case one by one. I'll just give here edge cases. So first one is let's go with the no profitable transaction possible. So while I say no profitable transaction possible, let me consider the input here 7, 6, 4, 3 and 1 here. This is fine. This is just the input. The output here will be 0. That is the reason I said no profitable transaction possible. Why? Here the prices are continuously decreasing, so no profit can be made here. If this will be the this one, we are not considering the first index. Suppose there is no here, this will be in the decreasing order, right? So prices are continuously decreasing, so no profit can be made here. This one is first edge case. Here no, I'll just give you no profitable transaction made. This is fine. This is the first step, and this is the first edge case. Let's go with the second edge case. Nothing but the single price in the array. Let me consider the element 5. Nothing but single element within the array. The output will be 0 here. Why the output will be 0 here? Since there is only one price here, no transactions can be made. So the output will be 0 here. I'll just write here single price in array. Right? So while I say single price array, since there is only one price, no transaction can be made here. So the output will be 0. This is the second edge case. And let's move on with the third edge case. Nothing but all prices are same. Let me consider the input. All prices are same. Let me consider the same number here. Let me consider 3. So the output will be 0 here. For this one as well, the output will be 0. Why? No matter which day we buy or sell, the profit will always be 0 here, right? So this is for all prices are same here for this one, right? Let's move on with the fourth edge case. Nothing but maximum profit from the adjacent days. I'll just consider the input 2 and 4 here. So the output will be 2 here. So why the output will be 2 here? We'll be buying the stock on the first day 2 and we'll be selling the stock on the second day. Nothing but 4 minus 2 here will be the profit will be 2 here, right? So we are buying the day, we are buying on day 1 and we are selling on day 2 to achieve a profit of 2. Nothing but 4 minus 2. This is what I have given here. This is for the edge case. Maximum profit from adjacent days, right? This is the fourth edge case. Let's move on with the last edge case. Nothing but minimum prices is at the start. Then I can just give here. Let me consider the example 1, 5, 3 and 4. this will be the input and the output will be 5 here. So why the output will be 5 here? So let's buy on the day 1. Minimum price is at the start. That's what the edge case is. So the first one we are considering, this one, let's buy on day 1, nothing but 1, and here price is 1 right here on the day 1. Let's buy this one on day 1, price is 1, and sell on day 4, this one, the maximum value here is 4. Day 4 we'll consider this one 4. So this one we bought it 1 and we sold it, we are selling at the price 4. So here 4 minus 1, actually just give me a second here. Right, let me consider this one as 6 actually, not the 4. Sorry, this one is 6, or else we had to consider 5 basically. Let's consider 6, this one, nothing but here 6 minus 1, here the profit will be 5 here, right? So the output will be 5 here, and what is the edge case that we went here? Minimum price is at start. So these are the 5 edge cases that we need to consider. First edge case was for no profitable transaction made. You can clearly see here the output was 0. Single price in the array, the output will be 0 as well. No profit can be made. And the third one is all prices are same. Then also the output will be 0. And the fourth one was for maximum profit from the adjacent days. So adjacent days means next day itself, right? So 2 and 4 we got the profit of 2. This is one edge case. And finally this one was for maximum minimum price is at the start. This one minimum price, and the profit that we got here is 5. So minimum price is at the start. These 5 edge cases that we have to keep in mind. Next, let's start writing the code, and I'll just explain the code while writing the code itself, right? So then we'll be discussing about the complex. So as we had discussed in the approach, let's initialize the left pointer L and max profit max. So I'll just consider L equals 0 and max is also 0 here. So we have to loop through the prices starting from the second day, right? For that one, as we are starting from the second day, I'll just consider this one r equals 1, not r equals 0 here. So this will be length of the prices, and let's increment the r we have to increment, right? Let's increment the r here. So within the for loop, what we have to do, if the current price is less than the minimum price, we have to update the L as we had discussed, right? For that, I'll just write a simple if condition. If prices of R is less than prices of L, then what we will do, we will initialize L to R. So if the current price is less than the minimum price, we are updating the L. And the final step is we have to calculate the profit if we select R, and we have to update the max profit as well. So I'll just give you I'll just give max and prices of R minus prices of L. This is fine. What we had done, we calculated the profit if we are selling at R, and we have updated the max profit as well previously. So finally, we have to return the maximum profit after the loop ends. Nothing but we have considered the variable name max right here. So I'll just come here and give return max. Let me format the document once and let me hit the run. So the sample test cases are getting passed here. You can clearly see. Let me hit the submit now. So yeah, you can clearly see the code works absolutely fine. So let's quickly discuss the space and time complexities, right? So here the overall time complexity would be big of n. So we are going with the approach sliding window. We went with the approach sliding window, right? Nothing but the 2 pointers. So overall time complexity here would be bigger of n. So I'll just give here big O of n. So why the overall time complexity here is big O of n? Because we are traversing the array once, only once, right? We are traversing the array only once, comparing and updating the values in constant time. You can clearly see here. And also the space complexity would be here big O of 1. Why the space complexity would be big O of 1 here? We are not making use of any additional space except for the few variables. So the space complexity would be here big O of 1 here, right? So this one is big O of 1. I hope this one, the problem is, the solution is completely clear along with the complexities, right? So this is it. Thanks for watching, guys.